In today's video, we are going to find the centroid of an asymmetric eye section. This video has three parts. In the first part, we will define a thumb rule which will help us find the centroid of symmetric sections without the need to do any calculations. In the second part, we will explain the formula used to find the centroid of any section. We will know how this formula is made and what is the science behind it. In the third part, we will solve an example in which we will find the centroid of an asymmetric eye section as shown over here. So let us start the first part of this video, the thumb rule. It says that for symmetric sections, the intersection of two symmetric axes gives us the centroid of that section. Please note that a symmetric axis is such a line that divides a section into two exactly equal parts that are mirror images of one another. For example, let us take a rectangle. It has two symmetric axes, a horizontal line and a vertical line, both passing through its center. According to the thumb rule, the intersection of these two symmetric lines gives us the centroid of the rectangle. Similarly, we have a square and a circle. Both have two symmetric lines passing through their centers. The intersection of these symmetric lines gives us the centroids of the square and the circle, respectively. In the same way, a symmetric eye section has two symmetric axes, and their intersection gives us its centroid. But what happens if we have a section which has only one symmetric axis, such as an asymmetric eye section having a vertical symmetric axis passing through its center? The horizontal line passing through its center is not a symmetric axis because it is not dividing the section into two mirror images. For such a section, the centroid lies on the vertical symmetric axis, but its exact location is unknown because in this case we have only one symmetric axis and the other horizontal line is an asymmetric axis. For such a scenario, we have to do calculations about the asymmetric axis to find the exact location of the centroid. The calculations are done using an easy formula. The formula says that the moment of the whole area of a section is equal to the sum of the moments of each small area of a section. Let us explain this formula using an asymmetric eye section as shown. The asymmetric eye section is divided into three rectangles, that is a top rectangle, bottom rectangle and a vertical middle rectangle. Let us suppose the area of the top rectangle is A1, the area of the middle rectangle is A2 and the area of the bottom rectangle is A3. The total area of the asymmetric eye section will be A equals A1 plus A2 plus A3. Now let us take a reference axis about which moment of each area will be taken. Normally, if we are finding the centroid about the x-axis, we take the bottommost axis as the reference axis. And if we are finding the centroid about the y-axis, we take the leftmost axis as the reference axis. Since for the asymmetric eye section we need to do calculations about x-axis, so let us take the bottommost line of eye section as the reference axis. Now we need to define moment arm from the centroid of each small area up to the reference axis. Let us suppose y1 is the moment arm of area A1, y2 is the moment arm of area A2, and y3 is the moment arm of area A3. Since until now we don't know the exact location of the centroid of the asymmetric eye section, let us take an arbitrary point as the centroid of the whole section as shown. The distance between this arbitrary centroid and the reference axis is the moment arm of whole area of the asymmetric eye section as denoted by y. Now that we know the areas of each small section and their moment arms, the formula can be written as total area multiplied by its moment arm equals the area A1 multiplied by its moment arm plus area A2 multiplied by its moment arm plus area A3 multiplied by its moment arm. If we take the total area of the section on the left side to the right side of the equation, it will give us value of y, which will tell us the exact location of the centroid of the asymmetric eye section. Now let us apply this formula to an example of asymmetric eye section and find its centroid. The asymmetric eye section along with dimensions of its three rectangles is shown over here. For this eye section, we know the centroid lies on the vertical symmetric axis, passing through its center. So we only need to find the centroid location about the x-axis. The bottommost line is selected as the reference axis. The eye section is divided into three rectangles, whose areas A1, A2, and A3 are given as shown. The moment arms of each area are also given. An arbitrary centroid is selected for the eye section and its moment arm up to the reference axis is denoted by y. The formula to find the distance of centroid from the reference axis is given as follows. Let us put the values of a1, a2, a3 and y1, y2, y3 in this equation. After solving, we get the value of y equals 9.2. which gives us the location of the centroid for the asymmetric eye section. Now let us summarize the overall process. It consists of 5 steps. Step 1. Divide the whole section into small geometrical sections. Step 2. Define a reference axis about which moment of each small area will be taken. Step 3. Find area of each small section. Step 4. Find moment arm of each small area up to the reference axis. Step 5. Put values of areas and moment arms in the formula and find the location of the centroid. That's all for this video. I hope you found this video valuable. Thank you so much for watching and I will see you soon in the next video. Bye bye.